Hello and welcome to Level 1 Mechanics. Today's topic is kinetic energy. Kinetic energy is the energy of motion. The SI unit for kinetic energy is the joule. The more massive an object is, the greater its kinetic energy. So for example, a large truck barreling along the highway at 100 kilometers per hour has much more kinetic energy than a little Honda traveling down the highway at 100 kilometers per hour. And also, the faster an object is traveling, the greater its kinetic energy. So a little Honda traveling down the highway at 10 kilometers per hour has much less kinetic energy than a little Honda traveling down the highway at 100 kilometers per hour. All right. As with most things in mechanics, there's a formula associated with it. And in this case, the formula is EK equals 1/2 mv squared. All right, the EK stands for kinetic energy. M is the mass, and it's measured in kilograms. And V, of course, is speed. And it's measured in meters per second. So let's take a look at an example problem, and we'll solve this using the formula EK equals 1/2 mv squared. A 12,000 kilogram asteroid is hurtling towards Earth at 20,000 meters per second. Very fast. Just let me get rid of that. What is the kinetic energy of the asteroid? So once again, we write down what we know and what we don't know. All right? What we're looking for, so this is what we don't know, is EK. So let's just put a question mark there. The mass is 12,000 kilograms. That's one heavy rock. And its speed is 20,000 meters per second. That's one heavy rock traveling at one incredible speed. All right, so we take our formula, EK equals 1/2 mv squared, and we plug our numbers into that formula. So M stands for the mass. So where the M is, we put 12,000 kgs, and where the V is, we put 20,000 meters per second. So here we have it. EK equals 1/2 12,000 kilograms times 20,000 meters per second, and we square that. When we put this into our calculator, or you can do it in your head if you like, we come up with the number 2.4 trillion joules. Huge number. Okay, we may like to take off 3 of those zeros so we don't have to use up so much ink, and that would change it to 2.4 billion kilojoules. Okay, a little bit better, but we can do it better still if we use standard notation or scientific notation. We can change this to 2.40 times 10 to the 9th joules. Oops. That should read kilojoules. Sorry for that mistake. I'll give you another example problem. This is something that they like to do on your NCAA exams. Example, an 80 kilogram ostrich and her 20 kilogram chick run across the savannah at 10 meters per second. Which one has the most kinetic energy? Okay, looking at this question, and already what you know is that an 80 kilogram ostrich and a 20 kilogram chick moving at the same speed, obviously the 80 kilogram ostrich is going to have more energy. Okay, you can say that. Might get you achieved on the exam. If you want merit or excellence, you're going to have to add to that. You're going to have to show some calculations. So, we write down what we're looking for and what we know. What we're looking for is kinetic energy. We know the mass. Got an 80 kilogram ostrich and a 20 kilogram baby ostrich. They're both moving at 10 meters per second, so we write 10 beside the V. Okay, it's always a good idea to write these things down on your paper. All right, so let's calculate the mama bird first. She's the heaviest. All right, we use the formula EK equals 1/2 mv squared. Put in our numbers. EK equals 1/2 times 80 times 10 squared. 10 squared is 100, and half of 80 is 40. So 40 times 100 is 40,000 joules. So the mother bird has a kinetic energy of 4,000 joules. The baby bird has 1/4 of the mass. Okay, so that baby bird only has a mass of 20 kgs. So we use our same formula and we put in our numbers. All right, EK equals 1/2 20 kgs times 10 squared. We calculate it and we see our kinetic energy of the baby bird is 1,000 joules. That's 1/4 of the mama bird. The baby ostrich has 1/4 of the mass of the mama bird. So it's a 1-to-1 ratio, really. Let's look at another example. Again, ostriches. We've got two 80-kilogram ostriches, so now the ostriches are the same mass. And they're running across the savannah. One has a speed of 5 meters per second, and the other one has a speed of 10 meters per second. The question is, which one has the greater kinetic energy? Well, of course, you know it's going to be the one moving faster. Again, that will get you achieved, but you want merit or excellence, you're going to have to do some calculating. So, write down what you know and what you don't know. So, what we're looking for, kinetic energy. The mass, both ostriches are 80 kgs, and one ostrich is moving at 5 meters per second, the other ostrich is moving at 10 meters per second. So we'll start with the slow bird, use our formula, put our numbers in. Okay, we've squared the 5 meters per second, the speed, and that's 25. So 1/2 times 80 times 25 equals 1,000 joules. All right, so now let's take a look at the fast bird. This bird is traveling twice as fast. And logically you'd think, oh, it's moving twice as fast, it should have twice the kinetic energy. Let's find out if that's true. All right, we use our formula, EK equals 1/2 mv squared. Put in our numbers, and you can see we've got 10 meters per second in there, and we're squaring it. So that's 100. So we've got EK equals 1/2 80 times 100. And you can see 4,000 joules. 4,000 joules. That's not twice as much as the slow bird has, but 4 times the kinetic energy of the slow bird. So this means if you double the speed, you quadruple the kinetic energy. And that's because in the formula you square the speed. All right, and that's all for today. Hope to see you back for my next video. Bye now.